Jai Hind everyone. Myself Ravindra Kumar from Electrical Engineering Department. Today I am presenting on the topic source transformation in the subject Fundamentals of Electrical Engineering, for which the subject code is BEE 101 or BEE 201 depending upon covered in first SEM or in second SEM. This topic of source transformation, this is covered in the unit number 1, and I will be discussing about this topic in detail with numerical examples. So, if we see in this, using source transformation in circuit analysis, any voltage source in series with a resistance can be modeled as a current source in parallel with the same resistance and vice versa. For example, this is a voltage source having voltage V. It is connected in series with resistance R. So, if we convert it to a current source, equivalent current source, then the current source will be this, which is having a current V by R, that is the voltage of the voltage source divided by the series resistance of the voltage source, which is also known as internal resistance of the voltage source. So, current of the current source is V by R, and the same internal resistance R which was with voltage source, now it will become the internal resistance of this current source and it will be connected in parallel. Another important point, suppose these terminals are A and B across which this voltage source is connected. So, then when we are converting it to the equivalent current source, this current source will also be connected across the same terminals A and B. That is the important point during conversion. Similarly, if a current source is there which is having a current I and it is having internal resistance R connected in parallel, then suppose this is connected across the terminals X and Y. Then if we convert it to the equivalent voltage source, then the voltage of the voltage source will be given by the current I of the current source into the internal resistance R of the current source. So, the voltage of the voltage source will become R into I, that is this, and the same internal resistance R, it will now be connected in series with the voltage source, and this will be across same terminals X and Y. So, this is the method by which we convert a given voltage source to a current source, equivalent current source, or a given current source to the equivalent voltage source. The another important point, the internal resistance in a voltage source is connected in series and internal resistance in a current source is connected in parallel. So, these are some important points which are to be kept in mind when we are converting a given voltage source into equivalent current source or vice versa of it. Further, if we see some numerical examples of it, like here if we see in this question, we are to use source transformation to determine the voltage V. This voltage V is across these terminals, suppose these terminals are P and Q. Across these terminals, we are to find this voltage V using source transformation. Here in this question, we are given one voltage source of 6 volt in series with the internal resistance of 2 ohm. Suppose it is across terminals A and B. Another voltage source of 4 volt in series with the internal resistance of 4 ohm. Suppose it is connected across terminals C and D. So, this is the circuit given to us and we want to find the voltage V across the terminals P and Q with the help of source transformation method or source transformation technique. So, in this question, what can we do? We can convert the given voltage sources into the equivalent current sources and then the circuit will be simplified, and from there we will be able to find the voltage V across the terminals P and Q. So, as per previous discussions, if we do it, what can we do? when we are converting the voltage source to the current source, equivalent current source, then during the conversion across the terminus where the voltage source is connected, across the same terminus current source will be connected. That is the important point. So, if we do it, the equivalent circuit of this, that will be taken as first we are converting 6 volt voltage source into a current source. So, the current of this source will become 6 by 2, that is 3 ampere, and it will be having arrow in upward direction since the positive terminal of this voltage source is at upper side, and this will be like this, and this 2 ohm resistance, which is internal resistance of voltage source in series, that will now be in parallel with the current source of same value of 2 ohm, and it is connected across the terminals A and B. Similarly, the another source, which is 4 volt voltage source, when it is converted to the current source, then we will get a current source having downward arrow, reason being the positive terminal of this 4 volt source is at downward side. So, this current will become 4 by 4, 1 ampere in downward direction, and this 4 ohm resistance will be connected in parallel to this source since it is the internal resistance, and these terminals are C and D again. And now P and Q are these terminals where we are to find the voltage V. Now, if we see in this circuit, after conversion, we are getting this circuit. So, if we see in this circuit, what is there? We can see these 4 branches. One is this 3 ampere branch, another is 2 ohm branch, another one is 1 ampere branch, and this 4 ohm branch. All these are connected in parallel to each other. So, if we further simplify this circuit, we can take it like this. This 2 ohm and 4 ohm, they are in parallel. So, we can find the equivalent resistance of these 2 parallel resistances. Similarly, this 3 ampere current source and 1 ampere current source, they are also in parallel branches. So, we can find single current source out of these 2 current sources as a result of it. So, how do we do it? That we can see, if we see this 3 ampere current source, that will be supplying the current like this to the circuit, and this 1 ampere current source, that will be supplying the current like this. So, that means both these current sources, they are supplying the currents to this resistance and to this resistance in opposite directions. Since 3 ampere current source, that is supplying the current like this, and 1 ampere current source, that is supplying the current like this in 2 ohm. Similarly, in 4 ohm also, like this and this. That means these 2 sources, they are supplying the current in these 2 resistances in opposite directions. So, the equivalent current source will become 3 minus 1, 2 ampere. And it will be having upward arrow since 3 ampere is the bigger current out of the 2 currents from 3 ampere and 1 ampere, and 3 ampere current source is having upper arrow. That is why the equivalent current source or the resultant current source, that is 3 minus 1 ampere, and that is 2 ampere with upward arrow. And another thing, the equivalent resistance of 2 ohm and 4 ohm, that will become 2 into 4 upon 2 plus 4, and that becomes 8 by 6, that means 4 by 3, and these terminals are P and Q, where we are to find voltage V. So, now from this circuit we can find this voltage V very easily. This voltage V is the voltage across this resistance of 4 by 3 ohm. Since this 4 by 3 ohm resistance, that is directly connected across terminals P and Q. So, we can directly calculate this voltage V across this resistance of 4 by 3 ohm. So, V will become 2 into 4 by 3. Since this 2 ampere current that is passing through this 4 by 3 ohm resistance directly. This current is all this current is passing through this resistance, since the current is not distributed to any other resistance. This is the only one resistance which is in parallel to this 2 ampere current source. So, all this current is passing through this resistance. This current is not distributed to at any other place. So, this voltage V becomes 2 into 4 by 3, and that becomes 8 by 6 volt. So, that way we are able to calculate this voltage V in the given circuit, this circuit, with the help of source transformation easily. So, what we are to do in this, basically we are to convert the given voltage source to the equivalent current source, or vice versa, depending upon whether we are given the voltage sources in the circuit or we are the current sources in the circuit or whatever. So, here voltage sources are given in the circuit, we are to convert them to the equivalent current source, and then we are to simplify the circuit to the final step where we are having single source and having internal resistance with that, and then we can find the voltage, current, whatever we require. So, this is the method which by the help of which we can do it. Similarly, I will take some more numerical examples related to it, where we can apply this source transformation technique to find the voltage, current, etc. in a given circuit. Like for example, I take another numerical. We are having another source, another circuit. This is a 6 volt voltage source with 3 ohm resistance in series. Here we have 6 ohm resistance also connected like this. Then another 6 ohm resistance connected here. Then we have this 1.5 ampere current source then 2 ohm resistance, and then 5 ohm resistance here. Now, in this circuit, we are to find the voltage across 5 ohm resistance using source transformation technique. That means, we are to find the voltage across this resistance. Suppose this is connected across terminals X and Y here. So, we are to find the voltage across X and Y, or voltage across 5 ohm resistance which is connected across X and Y using source transformation technique. So, what can we do in this case? If we see the circuit carefully, we can see here this 6 volt voltage source is connected with 3 ohm resistance in series across these terminals. Suppose these terminals are A and B. So, we can convert this voltage source to a current source, equivalent current source, and then we can simplify the circuit in the other steps. So, if we do it, what will be there? If we convert it to the current source, it will become like this: a current source with the current 6 by 3 ampere. Since 6 volt is the voltage of the voltage source and 3 ohm is the internal resistance in series with the voltage source. So, the current source will be having a current of 6 by 3 ampere, that is 2 ampere, and this arrow will be upward, since positive terminal of the voltage source is upward, and 3 ohm will be now connected in parallel with the current source, and these terminals are again A and B. Since voltage source is connected across A and B terminals, so from the diagram we can see this is the voltage source connected across A and B. So, at the same terminals, current source will be connected after conversion from voltage source to current source. Now, further we complete the circuit. This will be this 6 ohm is also connected across A and B. Now, another 6 ohm, that is here. Then we have this current source of 1.5 ampere, and then this 2 ohm resistance, and then this 5 ohm resistance across X and Y. Now, if we see the circuit carefully, this 3 ohm resistance and 6 ohm resistance, they are in parallel across the terminus A and B. So, we can find single equivalent resistance of these two resistances of 3 ohm and 6 ohm. So, if we do so, it will be three into 6 upon 3 plus 6. This is the parallel equivalent of 3 ohm and 6 ohm. So, this becomes 2 ohm. 3 6 18 upon 9, that becomes 2 ohm across the terminus A and B. And further we have this 6 ohm, that is this resistance as it is, then this 1.5 ampere current source, then this 2 ohm resistance, and then this 5 ohm resistance across X and Y. So, now on seeing this circuit, we can see this 2 ampere current source is in parallel with this 2 ohm resistance across the terminals A and B. So, it can further be converted to a equivalent voltage source, and circuit will be simplified further. So, if we see it now, what can we do? In the next slide, I will take it. We will be having a voltage source which is having a voltage of 2 into 2. Since 2 ampere current source is in series with 2 ohm resistance. So, this voltage will become 4 volt and 2 ohm resistance will be in series now with this. If we go to the previous slide, we can see it. This 2 ampere current source is in parallel with 2 ohm resistance across the terminals A and B. So, the voltage, when we convert it to the equivalent voltage source, the voltage of the source will become 2 into 2 4 volt, and 2 ohm will be in series with that voltage source, and this will be connected across terminals A and B. So, that is that I am doing. We can see it here. This is this 4 volt voltage source in series with this 2 ohm resistance across terminals A and B, since current source is also connected across terminals A and B. Further, we complete the circuit. This 6 ohm resistance, 1.5 ampere current source, and 2 ohm resistance and 5 ohm resistance, they will be connected as it is. Six ohm, 1.5 ampere, and 2 ohm and 5 ohm. These terminals are X and Y. So, now in this circuit, if we say it, this 4 volt voltage source, it is having series resistance of 2 ohm and 6 ohm with this. So, it can further be converted to a equivalent current source. So, if we do it, it will become, the current source will be having a current of 4 upon 8. Since 2 and 6, they are in series, so total resistance in series becomes 8 ohm, 2 plus 6. So, 4 by 8 is the current, that is 1 by 2 ampere with upward arrow, since positive terminal of this 4 volt is upward side or upper terminal, and this 8 ohm will become in parallel now with this 1 by 2 ampere current source. Suppose these terminals are P and Q, so it will happen across terminals P and Q, and then the rest of the circuit will be connected as it is. So, this circuit is obtained after conversion from voltage source of 4 volt to a equivalent current source in the circuit. So, now if we see, this 1 by 2 ampere current source, this 8 ohm and 1.5 ampere current source, all these are in parallel branches. They are connected in parallel branches across these terminals P and Q. So, we can further simplify the circuit. We can find single equivalent current source. How can we do it? If we see the current supplied by these sources, this 1 by 2 ampere current source is supplying the current in this direction in 8 ohm. Similarly, this 1.5 ampere current source, that is also supplying the current in the same direction in 8 ohm. Both are supplying in downward direction. Similarly, if we can see it, it is 1 by 2 ampere current source, this is supplying current like this in 5 ohm, and 1.5 ampere is also supplying like this in the 5 ohm. That means both these current sources, they are supplying the current in same direction in different resistances. So, when we are taking the single equivalent current source of these two, then that will be the addition of these two currents of the two current sources, since both are supplying in the same direction. Current are supplied by the sources in same direction. So, it will become now 1 by 2 ampere plus 1.5 ampere with upward arrow. So, this becomes 1 by 2 plus 1.5, that becomes 2 ampere. So, this is the final circuit which we are having after converting from voltage source to current source or current source to voltage source, depending upon the circuit. So, if we see it now, this 2 ohm and 5 ohm, they are in series. That branch is connected in parallel with 8 ohm branch, and 2 ampere is the current of the current source. So, we can find the current in this 5 ohm branch using parallel current division rule. Suppose the current here is I. 2 ohm and 5 ohm, they are in series, so they will be having same current I. So, I will be given by 2 into 8 upon 8 plus 2 plus 5. This is using parallel current division rule. So, this becomes 16 upon 15 ampere. And when we are able to find this current through 5 ohm, we can also find the voltage across 5 ohm. So, this will become, suppose the voltage is V across 5 ohm. So, that will become 5 into I, and that becomes 5 into 16 by 15, or it becomes 16 by 3, or it becomes 5.33 volt. So, that way we can find the voltage across 5 ohm branch using source transformation. So, finally, the voltage which we obtained here, this is 16 by 3 volt or 5.33 volt. One more example I will take related to it. Like here in this circuit, we are having this current source of 120 ampere with downward arrow, and it is having a 5 ohm resistance in parallel to it. Then we are having, this is 50 ohm, not 5 ohm, and then we are having this 10 volt voltage source here with terminals marked. Then we are having 150 ohm resistance here, and with this resistance a parallel current source is there of 40 ampere with downward arrow. This is the circuit, and in this circuit we are to find the current I in this branch. Using source transformation technique, we are to find this current. So, how can we do it? If we see it, this is a very simple question. What can we do in this case? We can convert this current source of 120 ampere, since it is having 50 ohm resistance in parallel with it, which is just like the internal resistance of this current source. and when we convert it, it will be converted to an equivalent voltage source. Similarly, another 40 ampere, this current source of 40 ampere, it is having 150 ohm in parallel with this, it will also be converted to equivalent voltage source. And then after doing this, these conversions, the circuit will be simplified and we will be able to find this current I in the given branch here from the circuit. So, if we do it, it will be like this. This first I am converting this 120 ampere current source in parallel with 50 ohm resistance. Suppose this is across terminals A and B. So, it will be voltage source voltage will become 120 into 50 with positive terminal downward, since the arrow of the current source is downward arrow. That is why positive terminal will be downward. So, this becomes 6000 volt. And it is having 50 ohm resistance in series now with this across terminals A and B. Since current source is also connected across terminals A and B, then after this we are having this voltage source of 10 volt as earlier. Similarly, suppose this current source is connected across terminals X and Y. So, then we are having 150 ohm this is 40 into 150 with positive terminal downward again, since 40 ampere arrow is downward. So, it will be like this. So, this becomes 6000 volt also. So, this will be the simplified circuit and now we are to find the current here. So, if we observe this circuit carefully, this 6000 volt voltage source, this one, this 6000 volt voltage source, this one, and this 10 volt voltage source, this 50 ohm resistance, 150 ohm resistance, all these are connected in series in this closed path or in this mesh, whatever we call it. So, we can apply KVL and we can find this current I very easily, or other way we can also do this 6000 volt voltage source, it will be supplying current like this. This 6000 voltage source, this will be supplying current like this. So, we can see both these voltage sources, they are supplying the current in opposite directions in the circuit. So, the resultant voltage of these two voltage source will be subtraction of these two, and since both these voltage sources are having equal voltages 6000 volt, 6000 volt. So, net voltage will become 0 out of the two. So, the circuit will be simplified to this one. Like this, and now we can find this current I. So, I will become 10 upon 50 plus 150 and that becomes 10 by 200 or 1 by 20 ampere. So, this will be the value of current I in the circuit which we are to find using source transformation technique. So, these are the methods which we can apply for simplifying the circuit when we are taking source transformation method, and from that we are able to find the current or voltage in any branch. Another important point in this, ideal voltage source and ideal current source, they cannot be converted. That means, ideal voltage source cannot be converted to ideal current source. Ideal voltage source cannot be converted to ideal current source or vice versa. Reason being, the internal resistance of ideal voltage source is infinite. Internal resistance of ideal voltage source is 0, while the internal resistance of ideal current source is infinite. As per the characteristics of these sources. And in the very first slide we have seen that when we are converting a voltage source to current source or current source to voltage source, then the internal resistance of the two should be equal. But here they are having unequal internal resistances. That is why we are not able to convert the ideal voltage source to a equivalent ideal current source or vice versa of it. That we can see in the very first slide here, that internal resistance of voltage source and current source, they are equal. That is the condition applied. So, due to this we are not able to convert the ideal voltage source to an ideal current source or vice versa of it, since internal resistance of the two, they are unequal. That is all in this topic. I have taken the numerical problems related to it. So, all these problems that we are covering in this, they are important for simplifying the circuit. Jai Hind.